What if I told you this tiny device can track temperature, humidity, and pressure, store it, and even predict the weather completely on its own? Unlike cloud-based solutions that often limit API calls or lock features behind subscriptions, this project works entirely standalone, giving you full control with zero limitations. Access the live weather forecast directly from your phone through its built-in Wi-Fi access point. This weather station works anywhere, fully offline. Everything is logged directly to the SD card inside this weather station. Visualize past data instantly. Select any time range and watch the graphs update in real time. Let's see what we need to build this project. As a microcontroller, we are using Wemos Lolin32 with inbuilt OLED display. Display will show us IP address to access web portal. We are using SD card module to store our data in the card. This module works on the SPI interface. To collect data, we are using BME280 sensor, and for date and time data, we are using ESP32 RTC module. We also need some wires to connect all components together. And here is our wiring diagram. Please note, BME280 and ESP32 sensors will work on 3.3 volt. Let's go ahead and connect all things together. Connect ground of the SD module to ground of the Lolin32. VCC pin of the module to 5-volt pin of the Lolin32. Connect CA's pin of the module to pin 16 of Lolin32. Connect SCK pin of the module to pin 13 of the Lolin32. Connect Moji pin of the module to pin 14 of the Lolin32. Connect MISO pin of the module to pin 12 of the Lolin32. And with this, connections to the SD card module completed. Both our sensors, BME280 and RTC module, will work on 3.3 volt. Also, both sensors along with inbuilt OLED display will share same pins, since they all have different I2C address. Let's connect them. Connect ground pin of Lolin32 to ground pin of the BME280 sensor. Connect 3.3 volt pin of Lolin32 to VCC pin of the BME280 sensor. Connect ground pin of the BME280 sensor to ground pin of the RTC module. Connect VCC pin of the BME280 sensor to VCC pin of the RTC module. Connect pin 5 of the Lolin32 to SDA pin of the BME280 sensor. Connect pin 4 of the Lolin32 to SCL pin of the BME280 sensor. Connect SCL and SDA pins of the BME280 sensor to SCL and SDA pins of the RTC module, since they share same pins. Now all our connections completed. Let's go ahead further. To create standalone web portal on the access point mode, download asset files given in the description below. Make sure your SD card formatted to FAT32 file system. Maximum 16 GB SD card is enough for our project. Copy all asset files in the SD card and insert it into the SD card module. Now we are ready to upload the sketch. Let's go ahead and understand the sketch. Let's first take a quick look at the libraries included in this project. Each of them plays a crucial role to make this weather station work smoothly. We will need Wi-Fi.h, a sync TCP and ESP sync web server, SPI.h and SD.h, Wire.h, Adafruit GFX and Adafruit SSD1306, Adafruit BME280, and RTC lib libraries. Our inbuilt OLED display is configured to pin 5 and 4 of the Lolin32. We will also connect BME280 sensor and RTC module on the same pins. SD card pins: CAs 16, Moji 14, MISO 12, SCK 13 connected via VSPI on ESP32. BME280 and DS3231 are defined here. Provide access point details of SSID and password here. Global variables for sensor data declared here. Data logging settings. Logs sensor data with timestamps to SD card every 10 seconds in CSV format. OLED display functions. Initializes the OLED screen to display important messages like boot status and IP address. Used throughout the project to show system updates, errors, and key information clearly. Sensor and RTC functions. Read live environmental data from BME280 and fetch accurate date and time from DS3231 RTC. Automatically sets RTC to compile time date and time if backup battery is lost. This function reads temperature, humidity, and pressure from BME280 and fetches current date and time from DS3231 to update global variables. SD card and data logging. Initializes SD card and manages storing sensor data with timestamps in a CSV file. This function appends the latest sensor readings with date and time to the CSV file on the SD card. This function initializes all web routes and API endpoints for serving web pages, assets, and data. Main pages handlers serves the files index.html, data.html, and predict.html. Asset handlers serve JavaScript files like style.css, script.js, datalog.js, predict.js, and chart.min.js. Live Data API provides current temperature, humidity, pressure, and timestamp as JSON format to the web portal. Log Data API fetches historical data from the SD card and displays on the portal. Format SD API deletes and recreates the CSV file on the SD card. Prediction Data API returns sensor data from the last 3 hours and provides information. And Last Server Begin function starts the web server and makes the project accessible over Wi-Fi. And with this, we are ready to upload the sketch to our microcontroller. Hit Upload button and wait for the uploading process to complete. Access the portal and you will be amazed to see your project working like a charm. Here's the complete setup in action, fully self-contained, running completely offline. All the data is stored locally on the SD card, with no internet or cloud services involved. Now let's take a look at the web portal. Running directly from the ESP32, access right from the desktop browser. On the live data page, you can see the current temperature, humidity, and pressure being updated in real time. No need to refresh. Everything happens instantly. This is possible because the ESP32 is serving live sensor data directly, without any internet or third-party cloud services. Moving over to the historical data page, I can easily select a start and end date to review previously logged data. Once I hit apply, the page instantly generates a beautiful animated graph showing trends in temperature, humidity, and pressure over the selected period. And just below the graph, all the raw data is displayed neatly in a table format with precise timestamps, making it incredibly easy to review or export for further analysis. Everything you see here is powered entirely by this small ESP32, running completely offline, logging data to the SD card, and serving it through its own web server. It's clean, fast, and extremely practical for standalone weather monitoring. Thanks for watching. If you found this project useful or inspiring, don't forget to like, share, and subscribe for more practical tech builds. Till then, I am DHK Dude, signing off.